can share with you everything. Okay, so now we are recording. So I never done this before on Zoom to record, but at the end we'll find out how it works. Okay, so we will start now with the actual tutorial. You give the attendance by, someone's asking me how do you give the attendance. At the end, I will share with you a link to a Google form, and you will just write your email, name, and ID, and that will be your attendance. Okay, so today's tutorial is a combination of things in which we review the memory part and that we discussed before with more details, looking into stack and heap, and also understanding classes and the constructors behind classes. You might see a few things that you did not cover yet, like class composition, but you will cover it next tutorial or next class or the one after. But it's very basic concept that we will just like go over quickly. So to start with, by the way, this tutorial will require some interaction from you guys. So if you don't interact with me, it will be a boring tutorial maybe, because I'll be answering all the questions myself. But if you do interact with me, it will be a fun tutorial. So we will start with a very simple class. It's called account. And this account class has some private members. I believe you all by now know what a class is, what are private members, and what are public members. But now the concept of it will be more reinforced. So this is a class account. We have two private members which hold it's an integer, which is the account number, and a double with a double floating point, which is the balance. So you can think of this as a class for like bank accounts, for example. This is a bank account in which you can store the account number and how much money you have in it. Now, the public members, there are four public members here. Three are constructors and one is a destructor. So the first constructor is the default constructor. The default constructor is because it doesn't take any parameters. So it's just account and function call. A constructor always has the same name as the class. You do not define a return type for it. It's just, that's how you define a constructor. However, it can be a default constructor, which in this case does not have any parameters. It can be a regular constructor, which it can have parameters. And you can have multiple regular constructors as well. So in this case, we're passing an integer and a double. You can have another regular constructor in which you're passing only an integer to initialize the account number, and the balance you will initialize it to 0 by default. Or you can have a regular constructor that only takes the double, the balance, but the account number is automatically generated, for example, which you will do inside the constructor, of course. So now we will see how it works. Anyone can tell me what this constructor is? I don't know if you covered. Okay, it does say here copy constructor, so it's useless to ask you, but this is a copy constructor, which means if you have an account object, if you use this class and create an object, and now you want to make a new copy of it, you don't have to take all the all the values of account number and balance number yourself and then pass them to a constructor, again, to construct a new account with the same information. What you can do is that you can create a copy constructor. If you notice here, the parameter that is passed here is an object of account itself. So we pass an object of account. Anyone can tell me how are we passing it? Is this passed by value, passed by reference, passed by pointer? Okay, someone is saying it's passed by reference. This is passed by constant reference. We can notice the constant. Anyone remembers what that means? So first of all, passing by reference means that we are not creating a copy of whatever we are passing. We're passing a reference of the same object that is being passed to this function call or constructor. And a constant means that we are not allowing this body here, this body of this constructor, to make any changes to this object. So although we are passing it by reference, so we're not making a copy of it, but we don't want to allow this function to make any copy of it, or sorry, make any change to the same object. It can only read the values, which is exactly what we want here, because we only need to read the values to make a copy of it, to construct a new account object. So in here, we're passing another account object. It has a type account. It's passed by reference constant or constant reference. And inside the constructor, what we're doing, we are initializing account number, which is our member of the new account that we're constructing, to be equal to the account number of the another account in which we are passing. And the balance of this new account that we are constructing to be equal to the balance of the another account. So we're really making a copy of this another account to construct a new account out of it. In the default constructor, what we're doing is that we're simply initializing account number to be 0 and balance to be 0. In the regular constructor, we're passing an integer and a double to the constructor, and then we're initializing the account number and the balance using those values that we are passing to the regular constructor. Now, in each one of these constructors, we are also outputting account default constructor called, account regular constructor called, and account copy constructor called. This will help us understand what has been called after we run some examples. And the very last one is a destructor. Right now, it does nothing, like it's empty. By default, you will always have a default constructor and the default destructor. They will not do anything. So like by default, the C++ will have, C++ class will have a copy, it will have a default constructor, a copy constructor, and a destructor. It will not have a regular constructor. But they will not, so for the default constructor, it will not do anything. You should know that C++ does not initialize variables. So even if you create an integer in your main function or something, you have always to initialize your variables, because C++ does not initialize variables. The copy constructor, we will see later the difference between what is the default copy constructor and why you need to add a copy constructor yourself. The destructor as well, by default, it does nothing. Similar to this, but sometimes we will need to override it and implement our own destructor, which we'll also see examples of why we need that. Okay. Now this is implemented in account.h. It's a header file. So maybe I can move this whole code into Visual Studio, and we can also. Okay, shouldn't be a PDF. Okay, let me share the screen. Okay, so in here in the Visual Studio project, I will create a new file, add new item, and this will be a header file. I will call it account. And now we have this header file. You will notice here at the very beginning of the file, it's automatically saying pragma once. It's a preprocessor. When we have this here, it's a preprocessor. I'll let you know in a bit what it means. Can you guys see the font, or should I increase it?
I can see all right.
Okay. If some don't agree, let me know. I'll try to increase the font. Okay, so I'm going to delete this pragma once for a bit. Actually, I'll just make it a comment, and I will paste this whole code. This is the same code we were talking about. Now, one thing to notice is that, so first of all, this is bad. You should never, I maybe mentioned it before, you should never in a header file have using std. I know it's the code I'm writing before, but writing it in a slide is different than writing it on a, maybe we can do, if you want, using std cout and std and blind. Okay, this fixes it. Okay, and you will notice that I am also defining the function, everything inside the header file, which is not a good practice for a big project or anything. So we can, if you want later on, move them to a CPP file. But just for simplicity, I'm going to keep them in a header file. But usually what you would have, for example, is that you would define a function here. Let's say we're adding a function called print. So this is a member function of account class. This will be a constant function. Anyone can tell me what's the meaning of a constant function? So no, it's not static. So static has a different meaning. Static means that, so if you have here, let's say, static member integer, whatever, okay? For every object you create, yeah, you can change it as different than static. So static means that this whatever integer, for example, is the same exact one for every object you create of account. Like for all the objects of account that you might create, there will only be one integer that is being shared by everyone. This is what would mean by here, by static. So static as a keyword has a different meaning in C++ than what you meant with it here. But you are right in the sense that this print function call is not allowed to change the member. So if I do it here, so if I want to, for example, change account number to be equal to 1, it should give me an error. It's saying expression must be a modifiable L value because this is a constant. So if I remove the constant, I am allowed to do that. Okay, now I was trying to show you how to do a CP file. So in here, we just declared that this class has a function member called print. It has the return type of void, and it's a constant function. But we don't have a definition of what it does. Like we don't have the actual definition of what for this function to do. If you see here, also we have like a green line on it. Visual Studio can help us with few things, like automatically it can create definition of print in account.cpp. So if I click on this, it will automatically create the file account.cpp, and it will create the definition of this function. Let's do it. Okay, it's giving us a peek into the file here. But if I go to account.cpp, I can see it. This is a new file that was just created. It includes the account.h file, and it has the definition of the function called print. So when you're writing outside, let me go back to the account.h. When you're writing something inside the class definition, you don't have to declare that this is a print for the account class because you are inside of it already. But if you go outside of it, like in the account.cpp, in here, if I just write print, if I am just declaring a print function, it can't even be constant because it's just a global function in this case. So this becomes a global function behind my program in which it's just called print, and it's global. It's not part of the account class. But if I want to declare, not sure what I clicked. Okay, if I want to declare that this is the account print, I will have to specify that this is account, and you can see like I already get some auto names, like print is one of them. Now I am defining the print function of the account class. And in here, like we can do whatever, account number and balance if you want. We can just output them. So this is how you would define something in the, or declare something in the header file, and then define it in the CVP file. So what is the advantage of this? Like there are a few, I don't know if you've taken inline functions yet, but I will talk about a different advantage as well. When we are compiling a project in C++, the way the compiler works is that it will, for every, I don't know if you're able to read here at the beginning. Can we still have access to it? I don't think we do. So basically the way the compiler works is that it will take every CPP file, it will compile it, and it will create an object file out of it. So in here we have two CPP files, account.cpp and then source.cpp. If you notice quickly while running the, okay, in this case there was no changes, so it just ran it, it did not compile again. But if you notice the compiler when it's outputting something, you will see that it's outputting, that it's generating the code for account.cpp and then source.cpp, and then it's linking everything together. So what that means is that it will create an object file of account.cpp, it will compile it, and then source.cpp, and then it will use the header files to bring everything together. So if we implement everything in the header file, it means every time we recompile the project, it will have to recompile the whole code. However, if we implement things in .cpp files, we compile it now the first time, it will create an object file of every CP file, and then we make a small change to, let's say, the source file. And here in the main function, we make it a small change, and we recompile. The compiler will not recompile account.cpp because it already compiled it. It's still saved in your folders. It will only recompile source.cpp, and then it will link the whole project together using the header files. But if we put all the source code inside the header files, then every single time we recompile, it will have to basically recompile the whole source code. If you're working on a big project, it can make a huge amount of difference in time. With the projects you're going to work on for this course, probably you will not notice, but it is the good practice basically to implement things in header files and CSV files. There are other technical stuff in which you will learn about inline functions. I don't know if you've covered it yet, but we will run some examples about it later. Maybe not this tutorial, but in the future. But in short, an inline function means that, like right now, if we make a function call, if we have here whatever function, and we make a function call, basically the compiled binary behind this will make a jump to the memory in whatever this part is implemented or is generated in the assembly, and then it will go through the assembly of this function, and then it will make another jump going back to the main function. So this is a jump in the memory location to go to the place of the function, finish it, and then come back. If we say it's an inline function, or if we define the inline function, the compiler will try basically to, let's say we have here some code. The compiler, what the compiler will do, it will try to, instead of making a function call, to make a copy of the code itself and just place it here, place it wherever we are calling it. So this would be an inline function. It will, like, if you look at the assembly behind the compiled program, it will not even have a function called function example. We look at the main code, like the main function code, we will just see the output cout hello in here instead of a function call. So this would be an inline function. An advantage of having an inline function is that it can make things faster. However, if you're making so many, like, it can make things faster because you're not jumping anymore, you're just sequentially executing the code continuously. But if you're making a call to this function like 10 million times throughout your program, and your function is inline, it means you're having now 10 million copies of this function. So your program binary size can get very big, or relatively big. So everything in programming in general has advantages and disadvantages. So it's always like interview question 101. Seriously, from now you should just memorize this. Whenever you get a question, what is the best tool to do that? What is the best data structure for this? What is the best algorithm for that? The answer is always, it depends. Like that should be the first thing you say. It depends. It depends on many variables. How much you're using it, how much memory you have. Are you trying to, do you have a lot of processing power, like a strong CPU but very little RAM? Do you have low storage? There's many variables in which makes something better than the other. Okay, we're going a little bit off topic, so let's go back to the actual example. Okay, so going back to account.h, what we have here is a default constructor that outputs I am a default constructor, and then we have a regular constructor, and then we have a copy constructor, and then we have a destructor, and we just added a print function. Now, if you can notice here, we have some preprocessors, and these preprocessors, they are like, basically a preprocessor means that the compiler will handle these before it starts compiling. Like it will do something about it before it starts compiling, like include. This include is a preprocessor as well. So what this preprocessor is saying, if not defined, this thing here, account_h, if this is not defined, then define account_h. And at the end, we have end if. This is the end of the if statement. Anyone can guess what that means, or what does it do?
I would guess that it checks if it's already defined this header file before, and if it has, it just skips it. Otherwise, it'll define it now.
Yeah, exactly. So whenever you have, like, inside, let's say in the source code here, include, let's say, our account class, account, and let's say we make another include to the also account. So basically the way the compiler handles this is that it will go to the file, and it will basically copy the code and just join it together in one program, if you want to think of it that way. This is the linking part. It will just go to every header file including, and it will just combine it all into one big program. Right now, I'm going to just make this as comment, and just to see what happens. So right now, this is the header file, and in here in the source.cp, I'm including it twice. If we try to compile this, it will give us an error saying account class type redefinition. We are redefining the account class. Although we have it only once written in the account.header.h, but in here we are including the account.h twice. And the first time we're including it is going to take all the code, which is the class of account, and it will define class called account. And the second time we're including it, it will do the same thing. It will take the full class, everything in the code of everything in the file of account.header, and redefine it. Now, what this does is that the first time it will go through this account.h file when it includes it, it will say, if not defined account underscore h. So this is just a keyword that we wrote. You can literally write anything. You just have to be consistent. So a common practice is just to use the same name of the file, underscore h. But it's really just a keyword that you're defining to the preprocessor to keep track whether you have defined this header file or not. So in here we're saying if this word is not defined before, if not diff account underscore h, then define account underscore h and continue with the process, continue with everything here. Now the second time we come to it, if not defined account underscore h, it will be false because we've defined it the first time we came to it. Because after the if statement, if we find out that it's not defined, the first thing we're doing, we are actually defining it. So if we come the next time, this if statement will be false, so we will not go through this header file again. The same example right now, including two header files, I run it again, it works just fine. Because the second time it went into that include file, it was defined that account underscore h, and it did not include the code anymore. It jumped over till the point where it's an end if. This is the end of the if statement. So the if statement was false, it jumped into here directly. Now, Pragma once does this automatically. Like if you will see like right now when we created a new header file, automatically we had this pre-process of Pragma once, which does all of that. You don't have to do if not diff and define and then end diff. You can just have Pragma once. On some compilers like the default, or some IDEs like Visual Studio, the default would show you Pragma once, but if you use like CLion, the default will be if and diff define. It's just a practice, and basically when you choose something, just stick with it. Like if you're going to use Pragma once, make sure you're using Pragma once everywhere. If you're using this, make sure you're using it everywhere. Don't have a header file with Pragma once and another header file with if and diff. It's just a better practice to be consistent in your coding. That also applies to the naming conventions that you're going to use. Like for example, a class here in my case is starts with a capital letter and then everything is small letter. If it was two words, I would just combine it with another word like bank account, separating with capital letter, first word. In some naming conventions, you will see that they use dash to separate, or underscore, like integer bank account number. This is also the standard library of C++ convention. I'm not a fan of it. I prefer to like I start my members with small letter and then I separate each word with a capital letter. So bank account number, for example, and so on. The important thing is to be consistent throughout your whole source code and throughout your project. You shouldn't have a way of naming something in one file and another way of naming another thing in another file. Anyway, going back to, is everything clear so far? I'm gonna go back to the slides and start the examples. If you have any questions, let me know before we move on. Okay. So this is the basic class that we have. Now we're going to run an example in the source file here. We are basically creating two account objects, and that's it. Anyone can tell me what will the output be when we run this program? So this is the main function, and this is our actual account class. If we run this main function, anyone can know what the output will be in the console? So let's just look at the first line. We're constructing a new account object. Which constructor are we using? The default constructor, the regular constructor, or the copy constructor?
That's the default constructor.
The default constructor, because we're not passing any parameters. It's just constructing an object out of nothing. So what we should expect from the first line, because we're making a call to this constructor here, to see an output of account default constructor code, because that's what we're doing inside the default constructor. Now, as for the second one, what should we see as output? In here, we're creating a second account object called ACC2, but we're using the regular constructor in this case, because we are passing two parameters to it, an integer and a double. So actually, even on like Visual Studio, if I do this, it should give me some hints. Okay, I think because I'm using the same line. Sometimes it gives you hints, but I think because I'm running so many things on my laptop, it's being slow to detect the automatic analysis stuff, even to remove the errors after I. Anyway, so sometimes it will give you some. It will show you like how many like function calls you can have. Okay, so in here. Okay, so now it's like before it was taking the default constructor, but now in here, for example, I started to pass some parameters, and it's showing me here that I have a constructor that takes an integer and a double. I also can just go down and see there's another constructor that takes a copy constructor, and there's a default constructor. So these can help sometimes when you're like using a library that you don't necessarily know, or the standard library, and you can have like part of, like, it will help you understand what options you have. Like I told you, like this is a regular constructor here, but we can have multiple regular constructors. We can have a regular constructor that only takes an integer, and the double will be initialized to 0, for example, inside our constructor. So in here, we will have the option to just pass 2. Not right now, but if we add it, we will have that option. Anyway, so if we run this program, we will get account default constructor called and account regular constructor called, which is something we were expecting. Okay. So now let's change a few things. So now what should we expect the output to be? So let's start with the first line. It's very similar to the one before. We're constructing a new object, account, ACC called, and it's using the default constructor. So we should see an output of account default constructor called. And then we are outputting after account CCC, so that should be, we should see it as well. What are we doing here? Anyone can explain this line, what it's doing? Someone is saying we're making a copy. A copy of what exactly? Like, will we see any output from this? Like, just by this line here, will we see any output? Let's add a Let's add a breakpoint. So this is a breakpoint here. I just clicked on here and I added a breakpoint. And when you're running this in debug mode, we will be able to, the program will basically stop at the breakpoint. So it's not running the full program. It's stopped right here. Unless I run it again, or unless I run it specifically the way I want. So breakpoints really helps you debug everything, because you can notice here, I'm able to see what I have inside my memory. So this is the account object, because I'm still at this point. This line was executed. And what I have in memory right now, actually, it might have not been executed yet. The regular constructor has not been called, because the values are still gibberish. So I haven't used Visual Studio for a long time. Let me just find the. Okay, they're up here. So in here, you can have like step into, or step over, or step out. Like step into will take us actually into, this is annoying. I press step into, and now our breaking point is here. You can see it here. This is the yellow. So we stepped into the actual constructor. I'm going to step over. So it's now stepped over this line. Step over again. We can see inside the memory, the values change to 0, because we just executed this line here. Step over again. Now we are back. Now we are back to here. This is the yellow thing. Step over. Now we are here. You can see the output, but here it is. So executing the first line, we saw that account default constructor called. Now, if we step over the second line, we see that after account ACC, and it also executed this line here, line 8, but we don't see any output. Anyone can tell me why we don't see any output? Like, what constructor was called here, if any? For this line specifically.
It looks like a pointer, but I'm not really sure what it does.
Well, it is a pointer. So what does it mean to have a pointer of account? Like, did we construct a new account object?
No.
No, because we only have a pointer. So this is a pointer of type account. It should point, or it can point to an account object in the memory. Right now, it's not pointing to anything, or it might be pointing to some gibberish stuff in the memory. But right now, it is not pointing to an account object that we created. And we definitely did not construct a new account object at this point. In this line, we only declared a new account pointer, which means it can hold an address that points to an account object. That's why we didn't see any output, because there's nothing new that was constructed. Now, after this line, if we go to here, ACC2, which is the pointer, we are assigning it to a new account object. We're using the new keyword to create a new object on the heap. We will go into details between the difference between stack and heap in a bit. But whenever you have a pointer, you want to allocate memory on the heap yourself, which you do by using the new keyword. So in here, we are constructing a new object. What constructor are we using here?
That's the default constructor.
Is it? We're passing 20 and 2.5. It's the regular constructor. The default constructor doesn't have parameters. So we're constructing a new account object using the regular constructor. What this will do is that it will create a new account object on the heap, the memory on the heap, and it will return the address of it. And this address will be stored inside this pointer. So after this line, we should see in the output that we have account regular constructor code. And in between the pointers, we did not have any output because we did not construct a new object. So let's go into some more details and look at the actual memory with this simple visualization that I have here. So after the first line, after account CC, ACC, basically the memory of every program has a stack and a heap. The stack, if you don't know what a stack is like when you stack things on top of each other. Whatever goes first has to wait till everything else went out to go out. So the last one that goes in will be the first to go out. Whatever I put on the stack on top will be the first that I will push out of the stack. So this is the stack memory. And with the stack memory, you are not responsible of handling creating a new memory and deleting memory. It's automatically done. However, the heap memory, so every program has a stack and a heap. The heap, you are responsible of allocating memory to the heap and freeing that memory from the heap. Like the program will not free the memory by itself. You will have to do it using the delete keyword. Whenever you use a new keyword, you will be allocating memory on the heap. And whenever you use the delete keyword, you will be deleting memory from the heap. As for the stack, it is automatically pushed to the stack. And whenever you go out of scope, it is automatically pushed out of the stack or popped out of the stack. So when we executed the first line, constructing a new object, this account object was created on the stack memory, which we can see it here in the stack memory. I just assume like I'm using k bytes as the size of account object. You can find out the exact size if you want when you're running it, but you might run it on different like environments and might give you different sizes, for example. Anyway, so this is our stack memory up to this point, or this is our full memory. Our heap right now, we didn't have anything inside the heap. We only added an account object to the stack. And then after creating the account pointer, ACC2, our pointer is also stored on the stack. The pointer, assuming running on such machine, it's an 8-byte, which holds an address to the memory, like to the RAM. But right now it's not pointing to anything. We did not initialize it to point to anything. But when we created this variable pointer, it was pushed to the stack. So you can see it on top on the stack, and the ACC object now comes after. When we assigned to the pointer a new account, this new keyword basically allocated on the heap, this part here, the heap, it allocated a new account object, which we can see it here in this box. It also has like k byte size. And it has an address on the heap, like this is your RAM. It has some address of memory on the heap, and it returned the address and it was assigned to ACC2. So now this ACC2 here is pointing to the address of this account object on the heap. Now, if we go out of the scope here, meaning go out of this function, things that are part of this scope will start popping out of the stack. So starting with ACC2, it will pop out, and then ACC, it will pop out and it will get destroyed automatically. However, the memory on the heap will not be destroyed automatically. So if you lose a pointer, if you lose the pointer pointing to that heap memory, it means you cannot access it anymore. It means you cannot go and delete it anymore, which is what's called by, you have memory leak. Whenever you hear the term you have memory leak, it means that you have some memory stored or allocated on the heap, but you don't have access to it anymore to delete it. So it's a leak. It's just going to stick there until your program terminates at the end and deletes all the memory it's using on the operating system. So this is the difference. Like we're going to see more examples as we go with these visualizations, but this is the difference between stack and heap. Stack, it's automatically handled and managed. The moment your variable goes out of scope, it gets popped out of the stack and destroyed by itself. the heap, you have to manage everything on the heap. You have to allocate memory using the new keyword and then free that memory using the delete keyword. Okay. So now let's introduce another class called owner. Okay, I'm gonna go to Visual Studio, turn this, I'm gonna remove this breaking point. I'm going to go to the source files. I'm going to add a new item, which is a header file. Let's call it owner. Okay. Okay, so the copy and paste doesn't work so well here. Anyway, I think I have it now. Okay, so this class owner, this is an owner class. It has 3 private members. The first one is a string. So string is part of the standard library. It handle like it's basically manages like storing, instead of using character arrays, it's much easier and probably better to use strings, except for some cases where you really need to use character arrays. Anyway, so for the owner, we have the name. For the number of accounts this person has, we have an integer. And to store the list of accounts that this owner has, so this is, we're assuming like this is an owner of like a bank account owner, and this owner can have multiple accounts. So we're going to see multiple ways of or 2 ways maybe of defining this owner class. This is the first way. We're storing the number of or the accounts this owner has. The member of the owner is an account object pointer to an account object called accounts. This is the part in which I said in the next lectures you will see what this means by using like an object of a class within another class. This is called class composition. But we can ignore that for now, like those technical terms. And it really works as if you created, like when we use string as a member of class owner, we're doing the same thing. Like string is a class. So it really works as if you have an integer or whatever. It's just a member of this class, which is also a class. But in this case, the member is not an object of class account. It's a pointer to class accounts, or it's a pointer to account called accounts. So in the default constructor of owner, what we have here is that we are first setting the name to be empty. So whenever we construct an owner, setting the name to be empty. And then for accounts, we are allocating an array of 3 of type account. So you're using the new keyword, and then we're saying, we're constructing an array of 3 account objects. So this is an account objects of size, or account array of size 3. And we're also initializing the number of accounts to be 0. Now, in the destructor of owner, this is important because now whenever you use new, you are responsible of deleting that memory you are putting on the heap. So whenever we are like constructing this owner class, we are creating this new memory, an array of 3 objects. And whenever we are destroying this object, we are deleting this array accounts. We are responsible of freeing the memory. So the moment we're deleting owner, we're going to free this memory and delete this array that we've allocated on the heap. Anyone have any questions about just this class itself? Okay. Can someone tell me what's the output of this program here? Remember the account class in which we have for every constructor that we call, there's an output that is going to be shown. So do you guys think that there will be an output just by constructing an object of owner? This is the owner class. So this is the constructor we're basically calling. Okay, I think I have some examples here. So the output that you will see is that we are constructing we're making call 3 times to the account default constructor of account. This is the output that we have on account. So why is this happening? When we have, basically owner is being constructed on the stack. We're not using the new keyword. This is what the owner object has. It has an account pointer called accounts. It has a string name, and it has an integer for number of accounts. Now, inside the constructor, what we're doing with accounts, we're constructing, or we're allocating on the memory using the new keyword an array of size 3 of type account objects. So it's actually constructing 3 account objects on the heap, just like this. We have an array of 3 account objects that are being constructed using the default constructor. And the first item of the array, the memory address of the first item of the array, is being pointed to this pointer, which is accounts. So just by constructing an empty owner object, we are constructing 3 account objects for this array. Now, the question is, do you guys think this is a bad design or a good design? So the goal here is to be able to store accounts for an owner. But this owner, the moment we construct this owner, might have 0 accounts. Yet we are constructing the maximum number of accounts we are allowing. And in this simple example, it is 3. But what if the owner can have like 100 accounts maximum? So every time we create an owner object, we will be constructing 100 accounts of objects, yet we are not using them. The way we are keeping track of the number of accounts is with this variable integer number of accounts. But we are forced to construct the full account objects every time, which makes this like a waste of memory kind of design. So how can we improve this instead of storing, like right now what we're doing is that we are creating one pointer that is pointing to an array of objects. We can change this design. Instead of storing one pointer that points to an array of objects, we're going to create an array of pointers that each one separately will be pointing to an account object whenever we need it. So at the beginning, all pointers will not be pointing to anything. But as we want to add account objects, we can start constructing those account objects one by one as we need them. So comparing this example to the previous one, if we have a maximum of 100 accounts that this owner can have, Now the memory we are creating at the very beginning when the owner is still have 0 accounts is 100 pointers, which is less memory than 100 objects of accounts. And then whenever we add a new account, we're going to construct a new account and just point it to one of those pointers instead of having the full 100 accounts being constructed and then just start using them whenever we need them. So the difference we did here in the account in the class owner, first we still have the string name, but now for the array, we're using the C++ standard library or C++11 standard library array class, which we saw an example of last time. And the type of this array is account pointer, and the size of it is 3, and the name is accounts. So the difference here is that we have an array that holds 3 account pointers. We are not constructing 3 account or a new array of accounts. We are storing the number of pointers that we want, which we will see now in the default constructor. So we're starting with name, we're putting it empty, number of accounts 0. And then we are going through every account inside our array of account pointers for integer I equal to 0, I less than accounts to size, and incrementing by 1 every step. We are initializing the pointers, every pointer inside the array, we're initializing it to null pointer. Because at this point, we do not need any accounts yet. It's simply empty, so it's a null pointer. Now, in the destructor, we also need to take care of the memory, although right now we still have not allocated any memory into the heap, but soon we will just implement an add account function, which we will start implementing things to the heap. So how do we take care of such freeing that memory if we don't know if it's allocated or not? The answer is by keeping track of the null pointer. So what we're doing inside the destructor, we're also going through all the pointers we have. For every one we are checking. If the pointer is not equal to null pointer, then we are deleting it. So in this case, if our pointer is equal to null pointer as we initialize it at first, we will not be calling delete on it. Because if you call delete on a memory that is not allocated, that's undefined behavior. Like your program might crash, it might behave weird, it might do stupid things. And you might just, and you also, like there's also an option in which you might not notice anything wrong. It's undefined. So this is how, like this is why it's very important to keep track of allocating or initializing the pointer with null pointer whenever you have nothing stored. Because this is how we're, in this case, managing deleting this memory. We're going to check if it is not null pointer, then we know that there's something there because we started with null pointer and then we put something there, so we changed that value. So now we can delete it. If it's still a null pointer, it means we did not change it, so we don't delete it. Any questions so far? So if we run the same example, if we run the same exact example, we will find out that there's nothing in the output anymore. Before we had three calls to the constructor, regular constructor of account. In this case, we have 0. Anyone can tell me why there's 0 output?
We use the default instead of the regular, and we didn't define how many accounts we want.
We use the default instead of regular of what?
When we were constructing the object own.
The object owner did not change. We like in terms of constructors, we only have a default constructor for owner. Even before, we only have one constructor for owner, so we only made one call to it. The difference here is that inside the owner, the default constructor, in here we had a one pointer of type account, and inside the default constructor, we were allocating a new array of size 3 of objects of account objects. So in here we were constructing 3 account objects inside the default constructor of owner. for this array. In the second example, this is still the default constructor of owner, but in here we're not creating any new account objects. We're simply just initializing these pointers of account objects to null pointer. So let's look at them in memory to have a better example. This is our memory after creating our owner object. There's nothing on the heap that was created. We only have an owner object on the stack. It has an array of 3 account pointers. These are the account pointers here, and each one is initialized to null pointer. So there was nothing constructed. There was 0 account objects that were constructed. And this is the main difference between this design and the one before. Before, we had to construct 3 account objects just by simply having that array, even if we're not using them. We had one pointer of account object, and it was pointing to an array of account objects. So our full array was on the heap, and on the stack, we only had one pointer inside the object. In this example, we have an array of account pointers, and at the very beginning, they are all null pointers. They are not pointing to any account objects. So each one of these is taking like 8 bytes, which is the size of an address of the memory. But there are no account objects constructed. In this example, we had one account pointer, and it was pointing to an array of all the objects that, the maximum number of objects that we can have for this account or this owner, which we define here as for simplicity as 3, but it can be much bigger. Did that clarify things? If anyone not getting this, like, please let me know. I can repeat the explanation. Okay, I'm gonna assume your silence is yes. Okay, so this owner class right now does not have a way to add a new account to the owner. We just have a way to store account pointers, or some, like, to be able to point to some account objects, which in the default constructor, we're initializing them to null pointer. In the destructor, we're checking if they are not null pointer and we're deleting them. But in this specific case, they will never be not null pointers because that's the only thing we're doing. So how do we add a new account to this owner? We're going to add a member function called add account. And what this function is taking an account by constant reference. So it's taking some account object that we're passing to it by constant reference. And now we're checking if the number of accounts we have is less than 3, that means we did not go over the maximum number of accounts. We're going to access the pointer array, which is accounts, at number accounts that we have at that index. And then we were going to create a new account object by making a copy of whatever account we're passing here. Here we're using the new keyword. So at this point, we are allocating a new account object onto the heap, and we're returning the address of it here, and we are assigning it to the pointer inside this array at this location. And immediately after doing that, we are incrementing the number of accounts we have just to keep track of the number of accounts, so that when we add a new account later, if the number of accounts is greater than 3 or 3 and greater, we will not do anything. We will output that amount cannot be added. We've reached the maximum number of accounts. If it is less than 3, we will be able to access the end of the array in which we have a free pointer, or a pointer or null pointer in that case. And we're going to use that pointer to allocate a new account object to it. So let's look at an example. This is still the same owner object that we created before. In here, we are creating an account object using the regular constructor, because we are passing the members 20 and 2.5. This is the regular constructor of account object. ACC2 is another account object that we are constructing, but we're using the default constructor. And then we are using the function of owner on own to add account ACC and add account ACC2. And this is the output of our program. The first line, account regular constructor called, which is for this line here. We are constructing a new account object using the regular constructor. And then we're using the default constructor to construct the second one. Now, why for these two lines, for each time we're calling add account, we're getting a copy constructor called? So the output for here is that we're making a copy constructor call to the account object. This is the implementation of add account. You can basically see it right here. We are constructing an account object or a new account object by passing to it another account object that we are passing to the function. So in here, we are using the copy constructor. This is not the regular constructor. This is not the default constructor. This is taking another account object, and based on that, it's making a copy of it to create a new account object. So at this line here, at this specific line, this is where we are making a call to the copy constructor of account. And this is why we see here, we are making a copy constructor called and a copy constructor called at these two lines. Now, we're gonna look into the memory and see what the hell is happening. So we have the owner inside the stack. This is very similar to before at the first line. We have the owner in the stack. The array of accounts has 3 pointers being initialized to null pointer. And then we have ACC, which is what's called with the regular constructor. We can see it being pushed to the stack on top of owner. It's right here. Then ACC2, it was also pushed to the stack. Like all these are stack memory. They are not being, we're not using the new keyword to allocate memory on the heap. These are all being constructed on the stack, which means freeing them or freeing this memory is handled by the compiler itself. It's not us. The program will remove them by automatically when they go out of scope. Now we're going to add a new account. So when we add this account, we are passing ACC to it, but we are creating a new account object inside the add account function on the heap, which is this one, by making a copy of ACC. And the pointer or the address of this account object is being stored inside the first element of the array. So our array now, the first element does not have a null pointer anymore. It has an address of this account object. And number of accounts right now was 0. Now it is 1 after adding this new account. When we add the second account, same thing. We are creating a new account object on the heap. It's making a copy of ACC2. And it is basically accessing the array of accounts at the index of number of accounts, which in this case, it is 1, which will be this item right here. And is creating a new object that is being stored, the address of it being stored at this element. And then number of accounts is being incremented, which now will become 2. So if we add a new account after that, it will come to this item right here, the third one, which is an index 2, 0, 1, 2. And then the number of accounts will become 3. So if we access, if we add an account again, it will give us that we've reached the maximum number of accounts. Any questions about what you're seeing right now? Like the way the memory is being stored? Any questions whatsoever? Because we're about to move to a more complicated step that if you don't get this one, you will probably not able to understand the next step. So if you have any questions, let me know right now. Okay, I'm gonna assume that that means you understood everything I said, I hope. Okay. Now, so before in the account object and the destructor, we did not have an output, but let's assume you added an output to every destructor, to the account destructor and to the owner destructor. When we terminate the program, everything on the stack here will start to be popped out. So the first thing we will see, this is the output here, account regular constructor called, account default constructor called, account copy constructor. This is for constructing everything. Now we're terminating the program. So we're going out of scope of the main function, and everything on the stack will start popping out. The first two things we see, account destructor called and account destructor called. And these for ACC2, the first item that will be popped out, and then ACC will be popped out. The moment it pops out, the destructor of that object gets called and it gets destroyed, which is why we see account destructor called and account destructor called. Now, let's say we added also to the owner destructor at the very first line of that destructor, an output of owner destructor is called. So after ACC2 is popped out and ACC is popped out, now own is going to get popped out. While it's getting popped out, they are not on Moodle, but I will send them by email to everyone. I also have a written explanation of all of this that I wrote once. So I'm going to share this with you as well. You might find some typos or something, but ignore those. I don't have a written explanation for every tutorial I'm going to do from now on, but this one, it's always important at the beginning of the course to understand all the concepts of memory. So I took the extra step and wrote an explanation once. Anyway, so going back to here, the owner destructor is starting to be called, and now we see account destructor called and account destructor called. Anyone can tell me why do we see the account destructor calls while we are destroying the owner? Going back to memory, this is the memory. It is logical because if you look at the memory, in total, we have 4 account objects. We have ACC, we have ACC2, and we have 2 account objects on the heap. Now, when we are destroying the owner object, if you remember in the destructor, what we are doing, we are going through every element inside the accounts array. We are checking if the account, if this pointer is not equal to null pointer, it means we are storing something. Or it's pointing to an object that we created. So we are going to that object and we're deleting it. So while we're destroying the owner object, this is why we see 2 outputs of account destructor is called, because we're destroying the first element and then we're destroying the second element. The third element is not being destroyed because it still has a value of null pointer. And this explains the output that we see right here. Okay. There's still one important concept that we're going to conclude with, which is probably the complicated thing I was telling you about. But if you understood everything right now, it will be kind of easy to digest. So, okay, this is just a simple. So in here, I'm asking if the add account function was taking things by value and not by constant. This add account, this is by reference, by constant reference. I'm asking if we're passing it by value instead of reference, constant reference, how much output change we will see. So the answer to that is that every time we're passing an account, you should see a new account being constructed using the copy constructor, because it will make a copy of it. And whenever you leave this add account function, you should see a destruction of that account object, because when you leave the scope, whatever passed by value, the copy of it will be also destroyed. So you will also see another destruction of this account object. You can definitely run it as an example and see that as output. Okay, so now we want to make a copy of the owner itself. We're going to start with this basic copy constructor. So this is a copy constructor of owner. And by the way, the default copy constructor, because I told you at the beginning, the default, like every C++ class has a default default constructor and has a default a copy constructor and has a default destructor that do specific things. For the default constructor and the default destructor, they do nothing basically. But for the copy constructor, this is basically the copy constructor that you have implemented by default. So you don't, if you're doing that, you shouldn't necessarily implement it. But now we will see why this doesn't do the job. So this copy constructor, it takes an owner object by constant reference. This form of copy constructor, like just memorize it. It is for every copy constructor you're going to implement, this is what you're going to be passing. You're going to be passing a constant reference to another object of the same class because you want to make a copy of it. And you want to make sure that, like, you don't want to pass it by value because you don't want the to make a garbage copy of it for no reason. And you don't want to pass it by pure reference because you don't want this function to be able to modify whatever you're making a copy of it. You just want it to be read only. So this is why you would pass it as constant reference. Now, what we're doing here is that we're initializing the name to the owner name of another owner that we're passing here. We're making a copy of it. And then the accounts. So this is important. This is the accounts array. And we're basically making a copy of this array coming from the another owner. And this is the number of accounts. We're also making a copy of number of accounts. Let's see what happens here. So this is this similar program to what we had before. This is the owner object, account ACC, account ACC2. We added both accounts to the owner object, and then we made a copy of owner. This is a new object of owner called own2, and we passed own to it, so we made a copy of owner. If we run this program and we add a breakpoint until return 0 if you want, everything will work just fine. The moment we terminate this program, so the moment we go out of scope and things starts popping out of the stack and object starts to getting destroyed, we will have a crash. Actually, so this will be our memory before we go out of the main program. We have the owner object, which was first added to the stack. And then we created ACC and ACC2. And then we added accounts to the owner object. So we made copy of ACC and ACC2, just like we did before, which are this one and this one. And then we made a copy of owner to a new object, own2. What did we do in this copy? We copied the name as is, we copied the number of accounts as is, and we also copied the array as is. So what happens here is that we did not make a copy of the account objects on the heap. What we made a copy of is the pointers. We made a copy of the address inside the memory because that's what the array holds. So you can see in this diagram, on the heap, we still have only 2 account objects. And this owner and this owner are both pointing to the same exact objects. The first element of this array is pointing to this object, and the first element of this array is still pointing to this object, because we only made a copy of the pointers, the address of the memory, and not the memory itself on the heap. So when we're going out of the main function, you will get an error. And in this case, this was run on Xcode using probably the CLang compiler. And this is the error you get. It's saying malloc error, which is like memory allocation. Error for object, whatever this object is, pointer being freed was not allocated. So in here, what this error means is that it was trying to free some sort of pointer or memory that is pointing to this memory. And it's saying that there was nothing allocated here that we're trying to free. So in debug mode, the compiler was able to detect that. Why is that happening? Can anyone explain why are we seeing this error? Why is it telling us that there's nothing allocated that we want to free and when it is happening exactly. Anyone, just make a guess. Okay. So when the program is starting to terminate, everything on the stack will start popping out and things will start getting destroyed. So the first thing on the top of the stack is owner 2. Remember, the last thing you put on the stack will be the first thing to go out. It's really stacking things on top of each other. So owner 2 will start being destroyed. We're popping it out of the stack. The destructor will be called, and the destructor will go through every account object inside the and every pointer of account. It will go to the account object that is pointed to, and it will delete it. So after destroying owner 2, this object is destroyed and this object is destroyed. Now account ACC2 is then popped out and destroyed, ACC is popped out and destroyed, and now it is turned for own, the owner object that has these values. The destructor will start going through every item in the array of these pointers. It will start with the first pointer. The value will not be null pointer because we basically initialized it first to null pointer, but then we put something there. So it still has an address. It will try to go to the address of here and destroy this object, but this object was already destroyed by owner 2 when it was destroyed. So there's nothing here to delete. And this is why we're getting the pointer you're trying to free was not allocated. There's nothing here to free, and you're getting an error. And so this kind of copying is called shallow copy. What we mean by shallow copy, it means that we're copying everything on the stack, but we're not making a copy of things on the heap that are part of this object. As we can see here, we made a new copy of the accounts array, new copy of the name, new copy of number of accounts, but those pointers still have the same exact values. We made a copy of the pointers. What we really want is to make a copy of the objects on the heap, not the same address of the memory. So this kind of copy is called shallow copy. And this is the kind of copy that is default by like any C++ class. If you do not implement your own or override the copy constructor in your class, you will have a default shallow copy. It will basically make a copy of everything that is not allocated on the heap. Now, how do we fix this problem? So this is basically the look of the memory when we are trying to delete owner or destruct owner, pop it out of the stack and destroy it. These pointers are still pointing to somewhere in the memory, but there's no objects there because we've already freed them when we destroyed owner 2. So now we're going to modify our copy constructor. The name is still copied as is. That's good. The number of accounts is still copied as is. Now, as for the accounts array, we are not copying the array, but what we are doing is that we are going to the objects that are being pointed to by this array, and we are making a copy of those objects on the memory, on the heap, and we're creating new objects on the heap for this copy of owner. So for every account inside the another owner accounts array, which holds 3 pointers in this example to accounts, if there is an account there, like if the account at that index of the array is equal to null pointer, so if there isn't an account there, we're going to initialize in this array, in this new account, on this new, like this is the new owner, and this is the accounts array of this new owner. We're also going to initialize it to null pointer. Like if that owner that we're making a copy of has no object at that account index inside the array, we're going to also put it as null pointer. However, else, if this another owner does not have a null pointer here, it means this owner has something pointed to on the heap. So this owner constructed an object on the heap and there's an account object over there. What we're going to do is that at this index of the account array, we're going to create a new account object. We're not making a copy of the address anymore. We're actually constructing our own new account object on the heap. But what we are passing to it is the account object coming from the another owner array. So take this line right here, another owner dot accounts at I. It basically holds a pointer to an object. And what we're doing is that we are dereferencing that pointer. So what this means is that whatever address is stored inside this pointer and the another owner accounts, dereference it, go to that memory address and get me that object. So it's going to get that object and is going to be passed to this account constructor, and this will make a copy of it. So this is a copy constructor here. We're basically going to the pointer or going to the address that is being pointed to by this pointer right here, getting that object and making a copy of it on the heap by using the new keyword, and then storing the new address of this new account object into our account array. Let's look at the memory and see what it means. This is the new memory if we run the same program with the new copy constructor. This is our owner class. It had an object, account object. This is the green one right here and the red one right here. And then when we made a copy of owner, we did not copy the pointers. We did not copy the addresses. We went to the heap of whatever this pointer is pointing to, and we made a new account object, but copying the values of this account object. So now we have another account object on the heap, which has the same copy of this account, and it is being pointed to by this account pointer right here. We did the same thing for the second element. And now in total inside the heap, we have 4 account objects. 2 of them are each 2 are copies of each other, but this owner is pointing to completely different account objects on the heap than this owner right here, although they are copies of each other. And this is what we call as deep copy. Deep copy is when you go into the heap and make a copy also of what memory we are storing on the heap. A shallow copy means that we're only making a shallow copy. We're making a copy of the addresses of that heap memory, but not the heap itself. The memory on the heap is still 1, and we're just making a copy of those pointers. And this is the difference between shallow copy and deep copy. Whenever you have pointers as members of your class and you want to implement a copy constructor, you need a deep copy. Otherwise, you will fall into this problem that we just saw. Like, you need a deep copy to be able to go into the heap and make a copy also of what's on the heap. Okay, any questions? It might be too much to digest, so you might want to give it run the examples again and read what the slides and the example I will provide you. And hopefully the recording will work and I will share with you the whole recording. But if you have any questions, please let me know right now.
If the deep copy really does copy everything, why would we ever use a shallow copy?
Why would you ever use a shallow copy? Well, there are reasons why you would want to, like I said at the beginning, the answer is always it depends. So sometimes you will have some use cases in which you want to use shallow copy. It really depends on what you're doing. But the most general purpose, like especially if you're dealing with like a structure of data in which like you have account and object, like that kind of stuff, you will definitely like always need to be having a deep copy. There are cases, I'm sure you will find cases in which you will take advantage of shallow copying. But in general, you should always, like if you're dealing with pointers, first thing you should do is be implementing a deep copy. Now, why does the C++ default copy constructor do shallow copy and not deep copy? Is because the C++ does not take care of the heap memory. It only takes care of stack. You have to take care of the heap memory. Like it doesn't even have a record of what's on the heap. It cannot know if this pointer has a value over there or does not have a value over there. It just sees like an address number. So like I would change your question to why this is not default in C++. And the answer to that is because it doesn't have the capability of doing it. You are responsible of managing the memory itself. And that's the thing about C++. It's the advantage and disadvantage of it. It depends who you ask. Like in other languages like Java, C#, things like that, you have what's called garbage collector, in which the garbage collector will take care about handling memory. It will find out that this memory on the heap does not have a reference to it anymore. Like there's no way you can access it. So at some point it will delete it automatically by itself. But in C++, you don't have that. Yeah, go ahead.
No, I was just saying thank you.
Oh, okay. So any other questions? Yeah, like I mentioned before, I have some of your emails, but now I will share a Google form that you will fill your emails and attendance for this tutorial. So I will be able to send you everything. What time is it? Okay, I'm right on time. Good. So I'm gonna share the Google form. Going to stop sharing my screen. No, there was no tutorial on Canada Day. It was a holiday. So please use this form, Google form, to sign your attendance and add your email. And here I have 20 participants. I believe I am one of them.